Good afternoon, everyone, and thank you for joining us. Cheyenne Dashnaw is hosting today. Your microphones are muted. If you have any questions or comments, please send them in and they will be addressed at the end. There will be questions posted throughout the presentation and you will have approximately 45 seconds to answer them. Certificates of attendance will be sent to all participants in a couple of days. And now I give you Cheyenne Dashnaw. Cheyenne, I believe you're muted.
Okay, I think I'm unmuted now. So today we'll get started now. So we're going to look at the life cycle of a hazardous materials project, the different phases and steps that we deal with as we progress through hazardous materials project, and how we coordinate that type of work with architects, owners, engineers, and other trades and the contractors performing the abatement work. So first off, let's start with what a hazardous materials project is. And what we're referring to when we say a hazardous materials project is kind of anything that encompasses, where we're doing some sort of abatement or remediation of a contaminant. A lot of times in buildings, we're looking at asbestos containing materials like containing paint, probably polychlorinated biphenyls and caulk materials, and then some other building components, universal waste products, like your fluorescent lamps, batteries, pesticides that would go out under a universal waste rule for management and disposal. And then other products that you might have, the conventional hazardous materials type containing items that you would follow the RCRA requirements for management and disposal. We'll also talk about when we're referring to hazardous materials project is what you might have on the exterior of a building. If you have subsurface contamination, whether it be petroleum from underground storage tanks or spills that have occurred in the past, metals, types of contamination, industrial facilities and places that would manage those types of materials, pesticides, whether that be applied agriculturally or in large quantities on a site where for weed killer management, it may have impacted ground surfaces or surface waters or even the groundwater. Buried waste, various sites we come across where they had old unpermitted landfilling activities in the past, and how do you manage those and deal with those? That would be we would classify that as part of a hazardous materials project. Then some emerging contaminants, your PFAS that many of you may have heard of, your per and polyfluoroalkyl substances from firefighting foams, or your manufacturing of Teflon or non-stick coatings, rainproof type products, where we're seeing a lot of that emerging as a contaminative concern. We also may have a hazardous materials project that affects water bodies such as your lakes, rivers, streams, retention ponds from different sites that may have contamination from settling out or discharges historically. When are we concerned with hazardous materials projects? Well, generally speaking, the conventional, a lot of renovation projects and buildings, you're going to have, at least the concern that there might be suspect hazardous contaminated materials in a building. Regulations dictate that, when you do a renovation, repair, or any sort of work that may impact suspect asbestos contaminated materials in a building, you would have to do the survey and assessment and abatement of that material before you can continue on with other work activities. So a lot of times when you are dealing with work inside a building, there is a requirement to make sure that you don't have those types of materials before you go and proceed with just doing the work as a general construction demolition type project. We may also have, when you're dealing with like I said, for like the exterior type scenarios where you might have subsurface contamination, petroleum products, PFAS, whatever that may be. That's a little bit more of a little more complex to determine if you have that concern. And usually you're looking at high risk areas. Do you have a high potential to have that suspect contamination? And then from there, okay, let's take that to an investigation phase and into remediation if we have to, if we do encounter something there. Not all projects will automatically look for that type of contamination, but if you do have a high risk scenario, it's usually better to plan for that and address it at the front end than to encounter it later on during the construction project. So during a conceptual design, preliminary design of a project, you really want to be asking yourself, is there a chance that hazardous materials may exist? And could these be potentially encountered or disturbed during the project? And if the answer is yes to either of those questions, then you should proceed. You know, it's good to proceed through the steps to make sure you're addressing those hazardous materials appropriately. So for purposes of our presentation today, we're just going to break it down into different phases of a hazardous materials project. And in here we show 8 different phases that, you know, we've generally categorized those as, you know, starting with a project definition, defining the project, knowing what we're working with, knowing what we're working towards in order to make sure those hazardous materials don't create a problem during or after the completed project. And then moving into survey and assessment of those materials, planning, design, abatement and remediation. And then after abatement and remediation, you're still not totally complete. You want to take it full cycle. You want to make sure you have site restoration and waste is disposed of properly. Do all the project closeout requirements and documentation, making sure everything's documented and accounted for. Taking those documents and those reports and records and making sure they're maintained and, you know, in a timely fashion. Certain records are going to need to be maintained for quite a period of time, so you want to make sure those are being met. And then further into long-term management. So if you have a remediation site where you weren't necessarily able to remove and dispose of everything, you might have a long-term component for management of those hazardous materials. All right, so step 1 with the project definition. First off, we want to know roles and responsibilities. Who's involved with the project? You know, is there going to be a hazardous materials designer? You know, are they and surveyor, designer? Are they going to be the same entity? But just make sure we have those established. Who's the owner? The funding agencies, architect, engineer. Who's reporting to who? Just so we know how to communicate and coordinate different activities during the life cycle of that hazardous materials project. Project funding and management is an important step. It's critical to know, you know, if there's certain agencies involved and what their requirements are for hazardous materials. You know, you do want to do the minimum. You got to do the minimum requirements, but some agencies may want to take things a step further, and they have written protocols as far as how you want to follow those procedures. So you need to know those up front, so that you're not getting in the middle of the project and realize that you didn't assess for something, you didn't account for something to meet their requirements and criteria. Areas of concern and scope of work, contaminants of concern, we'll go through those a little bit in the next few slides. Schedule, if you know what your design schedule is or your construction schedule, or both, important to lay that out up front. A lot of times that gets, you know, is taken care of as the design progresses, but it's good to know what those initial deadlines are, so we can try to coordinate a survey, try to coordinate the design to meet those goals for schedule. Site conditions and considerations. You know, you're not going to know everything up front, but if there are, you know, obvious things that are going to create an obstacle in doing a survey assessment, for instance, site access is going to be a challenge, or there's site operations that need to continue that you're going to have to work around. So knowing those up front, so you can scope a hazardous materials assessment and design, that's important to have that information provided. Historical data and background information. Sometimes you might already have some survey and assessment data. Obviously, you want to use that to full advantage, to full benefit. If things have already been surveyed and documented, and you know what the hazardous materials are, you know, there's no sense going back and trying to reconfirm that those hazardous materials are present if you know they've never been removed. So use that data, use it to your best to the extent that it's available, and don't duplicate efforts as if you don't need to. Then finally, an affected population. You would think on a hazardous materials abatement remediation type planning project, you know, why would it matter what the affected population is? Shouldn't you do everything pretty much similarly? Well, yes and no. It's good. You want to make sure that nobody's affected with a hazardous materials abatement or remediation or after that type of work is completed. But the fact of the matter is there are different requirements for different types of sites and facilities and who's there and what's going on. For instance, if you're dealing with a K through 12 school, especially 6 years and under, you're going to have all the most stringent requirements for asbestos remediation, and you have the most stringent requirements for lead-based paint abatement. So you want to make sure those are all accounted for that type of facility. If you're doing a demolition project, you can imagine there's going to be a little bit less stringent requirements and restrictions. You may not necessarily abate and remediate all your hazardous materials before you go through and demo the building. Some things may be left in place and you demo it in place. So you're kind of saving some effort in that. But again, it goes back to, okay, what's going on at the facility, who's the affected population. That's going to help decide how you go about and plan for those remediation activities. All right, so talking about the areas of concern and scope of work, this is one of the more critical items to identify during this project definition phase. Are we going to, if we identify our hazardous materials, are we going to plan to remove it completely? Or are we just going to plan to remove it to the extent needed to complete the scope of the project? If it's a renovation project, do we just need to remove hazardous materials as necessary to complete those renovations and basically get them out of the way? And then we're going to leave some other hazardous materials in place as long as it's intact and in good, decent condition. We'll leave it there. Become a problem for a future renovation, but there's project funding and all that in consideration. You may not be able to remove everything right out of the get-go. You might have to manage in place for the life of the building. Some other things, so we want to know, is the scope of the project well defined? That's a critical point. Sometimes, a lot of times through the design phase, things are still progressing. You're still developing that scope. So when you're doing a survey assessment, you may not have all the pieces of the puzzle yet. You may have to look at some different options as far as doing a survey and assessment and, phased approach, or, do the best you can at the front end, and knowing that there's going to be another survey assessment to complete as that scope might change during the design process. Another critical thing is making sure all the disciplines are coordinated to facilitate, a satisfactory plan and assessment for hazardous materials. Make sure that, a lot of times we work closely with an architect on their plans. There's electrical designers, mechanical designers, all the different trades. We want to make sure that a hazardous materials survey and assessment and design is going to cover their work as well. Last thing you want to do is get in the middle of a construction project and realize that the electrical scope wasn't appropriately accounted for on hazardous materials. And then you got a whole slew of additional abatement that needs to be done that wasn't planned for and is going to cost a heck of a lot more. So in the end, what you want to look at is the requirements of a hazardous materials project. And you want to mesh that with the expectations of the owner, client, architect, all that, and that's going to give you end result. Some projects, your requirements are going to be, they're going to want to do the bare minimum. So your requirements, your expectations are pretty much going to be one hand in hand, and that's going to be the end result. You're going to get the bare minimum, do what the regulations expect you to do, and nothing more. Whereas others, okay, we want to be a little more cognizant based on, again, the population that's here, based on the type of project it is, type of site. We want to be a little more cognizant, go above and beyond, typical requirements and address things to a little bit higher degree. So good to know those expectations up front so you can meet the requirements and the expectations and get the end result that everyone wants. What contaminants of concern do we deal with? I touched on this a little bit earlier, but again, inside buildings, a lot of times we're dealing with asbestos contaminated materials. They could also be on the exterior of a structure, or even in the exterior environment if bridge structures might have asbestos contaminated materials, things like that. So asbestos is a common one, and those do have stringent regulations that dictate that you need to be assessing, you need to do the sampling, you need to do the remediation or the abatement if it is there. So that's pretty well spelled out for you. These other ones are a little bit more complex to determine, okay, when and how should we address these. But you can have different contaminants such as metals. Lead and mercury are very common out there. Chromium, hexavalent chromium might be a contaminant concern. Cyanide. PCBs is a big one, whether it be in building materials or is it oil and different transformers, electrical capacitors, components. You might have contamination from that. So PCB cleanups associated with those types of scenarios. Volatile organic compounds, semi-VOC, total petroleum hydrocarbons, the glycols, those might be more observed in your exterior, your subsurface contamination if you had a spill incident. So you're dealing with soil remediation, groundwater remediation type systems, or vapor intrusion type issues. Pesticides, dioxins, furans. So dioxins, furans would be, your byproducts from an incomplete combustion type scenario. So if you have an incineration that occurred historically, you might have contaminants from dioxins and furans in the waste ash that should be cleaned up. PFAS, all those emerging contaminants. And then another category common in buildings, mold and radon. So, not necessarily things that you're going to remove, or, mold will be on bill of materials, but you also have that air quality concern, the air quality component. So is the mold affecting the air quality in the building? Is there radon gas seeping into a building that is affecting air quality, and we'll need a mitigation system installed. All right, so we defined the project. That was step one. Step two, we're moving into our survey assessment phase. We usually break assessment down into basically two phases. Phase one being an environmental site assessment, where we kind of do a preliminary evaluation of the property and see what we might have for concerns. And then phase two gets into the actual sampling, investigation, and analysis component. So phase two can include anything from your hazardous materials building survey, where we're sampling for suspect asbestos materials. We're sampling building materials to see what we've got in those. Or it could be your subsurface investigations, where we're doing the soil investigations, groundwater sampling analysis. We could also have surface water, air sampling, sediment sampling, sludge sampling, a lot of different sample analysis you might do depending on the area of concern, depending on the contaminant concern that you might want to include in that phase two investigation program. Also, vapor intrusion assessments inside a building. If you do have a spill incident outside the building, and your subsurface environment might have a conducive pathway into the building, you may want to consider those vapor intrusion assessments. See if there is an airborne pathway to the occupants inside. All right, for phase one environmental site assessments, you can do a standard standard process that you'd follow, such as ASTM E1527. That's a phase one environmental site assessment process, or an ASTM E1528, which is an environmental transaction screen process, which is more of a condensed phase one ESA. So you could follow something to that program, or you could do, if you're not looking for anything as extensive as that, you're just trying to get a preliminary evaluation of a site, you could do just a cursory review, environmental site review, where you target a certain area of concern, or you target certain contaminants of concern, kind of review different historical data and information, see if there's anything available that might help you as you progress through design and survey phase of the project. Main components you want to look at, though, during a site assessment is a site walkthrough and observations. It's really critical to get your eyes on the property, see what you can currently find on site, just by the visual observation that could, paint a picture as far as, where those specific areas of concern are that might be a costly remediation or abatement venture. So identify those up front, see what you're dealing with. You might look at historical documents. Maybe, like I said, you might have past surveys, past reports, or even regulatory agencies. If you search through the local or state or federal environmental records, see what they have on file for the site or nearby properties that might affect the site, and identify those. That'll help you continue on forward with an approach to assess your property. Discussion with key site personnel is another beneficial step to go through during this process. If you've had someone that's managed a property for several years, they're very they're vital to identifying things that you may not know or see during your site visit, and that can definitely go a long way to make sure that you can find things that maybe there's some materials in a wall cavity that you can't see, or a ceiling cavity that you can't access, and they can give you information details for that, or they can give you information on past abatement or remediation projects and how far those went, and maybe things that might have been left behind that still need to be addressed. On the phase 2 side of things, those site investigations, first off, we want to know what the areas of concern are. A lot of times we're going to identify that during the phase 1, or it's pretty clear and obvious. Yeah, we've got a tank out there. Let's go investigate that. That's our red flag area of concern. So you want to know where you're headed before you head there. So identify your areas of concern, develop your sampling program around those. You want to know what your contaminants of concern are. If you're dealing with a tank, you don't want to be sampling. You might not necessarily be sampling, petroleum storage tank, asbestos or things like that. You're going to be sampling for petroleum-related contaminants. So know what your contaminants of concern are, and detail that in your sampling program. Safety and accessibility, those are important. If we can't get to an area to appropriately assess it or safely assess it, then you have some limitations there. What can you do differently to work around those limitations? Sometimes it might just have to assume that you might have a concern there, put it in your project, and then at the time of construction, figure it out when you can implement measures to curb those safety concerns. Occupancy status of a property is important. Do you have to work around continued operations? Some facilities just can't shut down their operations, so you have to work around them the best you can. And that might, again, lead to some areas that you have to assume a worst case scenario and plan for that until you can get in there and do some sampling analysis. Equipment shutdowns, electrical deactivation. If we're sampling electrical components, obviously we need to shut those down so that we can safely access and sample them if need be. Can we do that while the facility is in operation or after normal hours of operation? All that comes into play when we're looking at doing a site investigation. Patching and repairs, to what extent do you need to patch and repair as you do your sampling? Certain facilities, if they're occupied and they're continuing to operate, you don't want to leave a mess behind. You don't want to leave things, chunks of bill of materials left out. You're going to want to do some patching and repair on that. Other facilities might not be as big of a concern. If you're going to demo a building within the next couple of months, maybe patching and repairing isn't really a critical item to do as you're going through that investigation process. And then finally, you want to look at your requirements. Obviously, you got to follow the regulations. Those are there in place to make sure everyone's on the same playing field, and that they're doing the best they can to appropriately investigate and assess a property or a building. But also, if there's certain work plans that dictate different means and methods or methods above and beyond those regulations, you want to make sure you're familiar with the work plan requirements or contractual requirements, in accounting for everything that's out there for the requirements on that project. Timing's another critical item in your survey assessment. Is when's the ideal time to do a survey assessment? There's a fine balance between going and doing an assessment early enough to get information back in time to correlate with your design deadlines, and not going too early so as where you don't have enough information to do an adequate survey. So maybe the design has not progressed to a point where it identifies everything that's going to be touched during the project. You can, in that scenario, you might just do a survey of the complete building and say, okay, we'll figure it out later. At least we'll have all the data or information. Or you do, if funding's a little bit tight, you might just do a partial survey and say, okay, we'll have to come back on another phase or another event once everything is figured out to do additional sampling if need be. So you want to look at those phased approaches. how you appropriately phase that survey. And sometimes you got the ideal situation where we can wait for everything to be designed, go do the survey, fit in the hazmat design, we got time. That's more of the exception than the rule, but just coordinate with everyone involved to make sure that we're doing it at an appropriate time, and information will be available when needed. We also want to look at site operations working hours. Again, do we have to work outside of normal business hours? And then seasonal considerations is another thing to pay close attention to. Subsurface investigations are obviously a little easier during your warmer months when you're not fighting snow or ice and things like that. But on the flip side, when you're looking at a vapor intrusion assessment, when you're looking at radon or indoor air quality concerns from volatile organic compounds, your colder winter climatic conditions are better to assess. That's going to give you a worse case scenario, being that the buildings are going to be closed, more tightly shut up during those wintertime conditions, and you're going to have snow cover and such. That's going to kind of give you a little bit more of a stack effect to bring that material in through the interior environment than out through the exterior ground surface. All right, with that brings us to question number 1.
Cheyenne, you can continue.
All right, question number 1, true or false? Survey and assessment should be the first step for a hazardous materials project. The answer there is false. That first step is defining the project, and then we can figure out how to survey and assess it. All right, so now we're moving into our plan design phase. Step 3, as we go back to that original slide there. What we're doing in abatement and design is we want to basically identify, locate, and quantify these materials that need to be removed, remediated, or otherwise addressed during the project. A lot of this information is going to be based on what we did find out during the survey and assessment phase. We're going to use that information to plan our design and include that in your drawings, your specifications, whether you need to create work plans. Sometimes you have variances. This is common with asbestos contaminant abatement. A site-specific variance will allow you to do methods differently than what is specifically called out in the regulations. That's useful for a lot of different reasons, but basically whenever you deviate from the regulations, you would need a variance to allow you to do that, and that would have to go through approvals on the state level, sometimes federal level, on different things. Then you want to look at when you're doing an abatement plan design, okay, specify what the applicable regulatory requirements, or maybe not necessarily as a specific regular requirement, but there's an industry standard protocol for how to remediate or abate a material. For instance, mercury containing flooring. There's really no specific regulatory requirements on how to address that, but it's good to have tried and true methods to make sure that work is done efficiently, effectively, and safely. And so there are some industry standards that you go about doing that type of work. It might mirror, a typical asbestos abatement project or have similar type activities with that. But again, tried and true methods that allow you to safely say or confidently say we can get this work done in a safe and efficient manner. Also in abatement design, you want to look at, describing some general descriptions of methods that would, 1, limit exposures to workers, occupants, and the environment, and then 2, get the work done in an efficient and cost-effective manner. Abatement and remediation, it's not always an inexpensive venture, but the more you can do on the plan and design phase, to identify the general methods that can be applied to get it done cost effectively, the better it'll be for the overall project. Now, we're not specifying specific means and methods, you know, like any other type of work activities. That's going to be more the contractor's responsibility is the specific means and methods, but just give them a general idea. Okay, this is where we're headed. This is, you know, this is what you're up against. This is how we want to try to address it, generally speaking. Definitely some coordination that we'll go through during the design phase. Again, usually on renovation projects, the abatement designer, it's not just the hazardous materials remediation abatement. You're coordinating with all the other trades. You want to make sure that all that work is appropriately coordinated. You know, there might be different design phases, 60%, 90%, 100%. And a lot of times with hazardous materials abatement, if you know what you're dealing with up front, a lot of that is going to be included in those early design phases. So you might have, you know, every other trade might be at 60%, whereas the hazardous materials design is probably more like 90%, 95%. And then they would tweak it as they go if scope was added, modified, or deleted. Speaking of that, you want to make sure that you are coordinating with all the trades, and you do know when a scope is changed. The last thing you want to do, again, you don't want to miss something. You don't want to neglect to observe areas that may have been added through the design phase. So keeping in touch with the actual scope of the project and how that's being modified during the design and planning phase is important. Sometimes you get a scenario where a project becomes delayed, whether it's funding, whether it's timings. You know, they still want to think about some things over a period of time. So you can imagine if something gets put off for 2, 3, 4, 5 years, but that facility's still operating, that facility might still be doing small projects here and there to remove different materials or do different renovations. You know, when you come back to it, you're going to want to do some additional assessment, make sure you know what may have changed, and account for that appropriately in your design and your planning. Maybe your regulations changed. Maybe there's a more stringent requirement, you know, that 2 years ago you didn't have to do, and now you have to add that into your project. So important to relook at things if you do have a delayed project. Known conditions, potential for hidden conditions, you want to identify those. If there's a high risk or a high potential for something to be in a wall cavity, plan for it. You could always either set an assessment up, you know, do initial work area to try to assess those on the front end, or you could do it during the construction phase, but definitely plan for it, because you don't want someone else tearing into it and being exposed to something that they're not prepared to be exposed to. Building conditions, contingency allowances, we'll talk about those in the next few slides. On building and site considerations, sometimes you have a scenario where you have contamination that needs immediate response action. It can't wait through the design phase and into the construction phase, you know, whether that's 3 months, 6 months, a year out. Sometimes it has to be addressed immediately. So if you have obvious spill incident that, you know, is affecting, you know, environmental resources, immediate response action needed, you'd want to get someone on board and do that before the project. Another scenario is specific contaminant materials. Sometimes you have an incidental disturbance condition that's in an area where that people are accessing routinely or will need to access routinely. You can't really wait to clean up something like that. You might want to get that done ahead of time, get it out of the way, and then people can continue to work in there until that project goes to construction. A lot of different logistics when you're looking at building and site considerations. Safety being, you know, of paramount importance. Can we safely access materials to abate them and remediate them? First off, can you safely access them, investigate them, and then, you know, can you get in there and remediate them? Sometimes you have to identify that for the contractors to plan appropriately, so they can install safety measures or bring in appropriate equipment to safeguard against those hazards. Facility building security. Is it a type of facility where you need it's at heightened security, that you need possible escort into the facility, escort out of the facility during your work. So all that should be planned during that design phase. Utilities, how are we going to get power, electrical, and water to do the abatement remediation? Will the facility provide it? Will it be accessible from the facility, or do they have to bring an outside source in? You want to identify that up front so they know what they're getting into and they can plan for it and put that in their bid costs. Structural integrity, when you remove a material, it may not be necessarily good for the structural integrity of that building. So how do we plan for that? Do we need to, is it something beyond what the abatement contractor can handle as well? So do we need to plan on some allied trades type scenario where someone else who can do that work can come into the work area, set up some controls, some systems, some temporary structures to allow that structure to remain intact as they're removing the contaminants of concern. Neighbors and public, is there a concern with your work activity that might infringe upon what they do on a normal routine basis? You definitely want to be good neighbor. You definitely want to be a good neighbor, so account for those during your plan and design can go a long way to keeping things from going off the rails when you get into construction. Adverse effects from typical abatement remediation methods. When we're doing asbestos abatement, when we're doing a lot of other hazardous materials, we're using wet methods. We're trying to keep those fibers, that dust, we're trying to keep it at bay. Water inside a building isn't always the best thing. So is there a way to control that and make sure that we're not going to create another problem after we do the abatement remediation by damaging materials to remain? So you want to make sure that that's addressed before you get into the project. And then another thing, lastly, perception in aesthetics. This is not necessarily something that you would be required to deal with per regulations. It doesn't necessarily have to be pretty. It doesn't have to be, look good to the public, but there can be a lot of headaches that are caused if people get the wrong impression by the way a abatement project site or a remediation project site appears. So it's definitely important to keep that in mind. And sometimes you have to go the extra mile just to make sure the perception and aesthetics of a project are on par with what might be expected from the general public and others. Contingencies and allowances. First off, all surveys, assessments, they're going to have limitations. You can't sample every bit of soil. You can't sample every material. You can't access above every ceiling tile. Things happen. They're going to have their limitations. Things might not necessarily be accounted for in a plan or a design or during a survey. So you definitely want to look at having contingencies and allowances on any hazardous material abatement and remediation project. You're going to run into some unknown conditions. If you don't, great. You can put that money towards something else, but definitely plan for it because there's a strong likelihood there might be something that you've got to spend that money on. And then even minor project scope changes during a construction phase can result in a significant cost increase. So it might not necessarily be related specifically to the abatement remediation work. You might have something, okay, an RFI was put in for electrical or mechanical type scenario, and okay, we can resolve it by doing this. Well, by doing this activity that resolves this problem, we've got to get into some of the asbestos containing materials that we wanted to leave behind and intact and not have to deal with. So again, that contingency allowance will allow you to get in there and remediate that extra material so you can resolve other issues or items that come up. And also on this front is when you're dealing with hazardous materials, you don't always have the luxury of an alternative approach. If it's in the way, if it needs to be dealt with, it needs to be addressed, and you need to remove it, there isn't nothing to it but to remove it. You can't pretty it up. You can't go some lot less cost-effective method to address it. You've got to deal with it. So that's another big reason why contingencies and allowances for hazardous materials are important, because a lot of times you're going to be set with one approach, and and it's going to cost what it costs, and you got to have the money and funds to do that. All right, so now we're going to go with question number 2.
Cheyenne, you can continue.
All right, question 2. Which of the following is not typically included in the hazardous materials project plan and design? Answer there would be the specific methods to remove and handle hazardous materials. All right, step 4 in the process, we're looking at abatement and remediation. Some different components of that: pre-work coordination planning, abatement remediation, the actual work, then the remediation monitoring, and then clearance and confirmation after you're done, just to make sure everything was done appropriately. Pre-work coordination planning, we got submittals that we'd be looking at. A lot of times you're looking at a work plan, making sure the contractor has identified what the work is and that they've got a plan to address it, and that correlates nicely with the design approach. A schedule, license certifications, waste hauler disposal permits, making sure that they're using permitted facilities for all the transport and disposal waste. And if there's any insurance requirements that the owner will want to have on hand before the work. A lot of times there's a pre-work meeting just to make sure everyone that's involved with the project is on board with what's going to occur. You know, these once you get in remediation abatement, you've got a section of the building or the property that's controlled in the work area. So making sure that, okay, once we go, that you can give up that area for the amount of time it's going to take to do that remediation and abatement, and everyone can work around that schedule and coordination. And then notifications, certain, like asbestos will have notifications to the state and the EPA. So there's certain time frames to make sure you're complying with those notification conditions. The work itself, there are certifications and licenses for certain types of hazardous materials. Whenever you're doing in New York State, for instance, whenever you're doing asbestos remediation or asbestos abatement, you got to have certified workers doing that. Mold, we do have licensure and certification in New York State for mold. Other types of scenarios, say you're removing a petroleum contaminated soil, there aren't any specific certifications required for that, but you might want to look at, okay, do we have an experienced and knowledgeable contractor in that field? Maybe throw out HAZWOP or type training to know that they've been familiarized with how you address emergency response activities. So, you know, even if there isn't a certification or license required, you might want to look at specifying something in there for experience and whatnot. Isolated contained work area, you want your work area preparations part of the remediation work. Then they're going to go through with their actual, how they're going to address the material. They're going to move it, they're going to encapsulate it, maybe they'll enclose it or some other type of treatment. So that'll be what's specified in design and in the work plan, how we're going to address those materials. Once you're done, either on a daily basis or, you know, at the end of a work shift, all that, you're going to have a decontamination. You want to make sure that people coming out of the work area that they're being able to decontaminate appropriately, not taking those hazardous materials home with them. And then also waste, or you might be decontaminating different waste materials or tools, equipment after the work is completed. Some very important things for hazardous materials: work practices, safety, again, that's paramount importance. Engineering controls, make sure that things are in place to keep those hazardous materials as limited as possible. Work methods, specialized equipment they might use. On the monitoring side, different asbestos mold, you may require a third party to perform this. lead. So when you do the monitoring, you're looking at daily inspections of a work area and how that progresses, making sure that the routine work is being done as it's specified or in accordance with regulations. Coordinate with those regulatory agencies, the owner, contractor, designer, laboratory, make sure everyone's apprised of what's going on. If there's any discrepancies or issues, bring that to someone's attention so it can be taken care of in a steadfast manner. The sample collection and waste, sometimes waste characterization will be done by the monitoring firm before disposal is completed. When we do the monitoring, you're gonna have an abatement clearance confirmation. You're gonna want to review your plans and specifications, making sure that work was done in accordance with the requirements. You want to confirm that clearance criteria, whether it's a regulatory requirement or if it's a project-specific requirement. A lot of times you're always going to have a visual inspection. You want to make sure you're not seeing the issue anymore. You also may have some component of field monitoring, whether you're using a field instrument like a photoionization detector for volatile organic compounds, a particulate monitor for general air monitoring, or a mercury vapor analyzer. So these tools can help you determine, okay, yeah, we're looking good, real-time instrumentation, and then we can go through and do a sample analysis to verify and confirm. A lot of times that's air samples. Also could be wipe samples or bulk or soil samples to make sure everything looks good after you completed the work. So when we do get our clearance, we either have one or two things are going to happen. It's either going to fail or it's going to achieve clearance. So if it fails, we got to go back. We got to do additional removals or cleaning, re-cleaning, do additional inspections, additional sampling until we can get that work area to pass. If you can continue to fail, maybe there's something, you might need to stop work, figure out a different plan, and go back at it when you have something that might work a little bit better. Or the alternative, the other thing is your clearance is achieved, then you can move on to dismantling your work area and restoring the site. All right, question number 3.
Cheyenne, you can continue.
All right, question 3, true or false, contractors need to be licensed or certified to perform any type of hazardous materials abatement remediation. The answer there is false. There are some that don't require a certification or license, but again, you want to have someone who's experienced and knowledgeable. All right, moving to step number 5, site restoration, waste disposal. We completed the abatement, we completed the remediation. Now we've got to go back and everything's cleared. We got to dismantle the work area, so that involves removing all your temporary barriers, fencing, going through like a punch list inspection, making sure that you're leaving the building and property in a satisfactory condition for other trades to come in and do their work, or to turn it over directly to the owner so they can continue on with their operations and activities. So we want to make sure there's no damage, there's no things left behind residue, and everything's in a good condition. Waste disposal, there are regulatory requirements for transportation and disposal, also for storage and transport timeframes. You want to make sure you're not storing that waste on site for too long. If you're dealing with hazardous waste, you're going to have requirements, whether a small quantity generator, you're looking at 180 days generally, or 90 days for a large quantity generator. So you got to get that waste out of there in that time frame. So plan for that accordingly. As a universal waste, you have up to a year to transport that waste. A lot of times at the end of the project, you probably don't want to wait a year to get it out of there. Contractor is going to want to get their payment. So hopefully it's done a lot more expeditiously than that. But there are those requirements you have to comply with. And then some other things like petroleum contaminated soil. A lot of times you're looking at a 90-day period for that because it is a solid waste, consider a solid waste. So try to get that out as quickly as you can, but definitely don't straggle on too long. Step 6, the next step, we're looking at that project closeout and documentation. So document materials that may remain. So especially if you're covering material, you're doing some sort of enclosure, you want to document where that material is enclosed so that nobody just goes and rips into that wall or ceiling or whatever it's enclosed with and finds it unexpectedly. You want to make sure that, okay, if we're going to do work there, people are going to know we really got to do it on an abatement condition because what's behind it. Waste disposal documentation. It's critical that if, especially dealing with hazardous waste, universal waste, those asbestos waste, that everything is tracked appropriately and there's a paper trail and things are returned to the generator in a timely manner. So once it gets to the disposal site, from the time it's taken off site through to the disposal facility back to the owner, you want to get those manifests back. Generally, it's a 45-day requirement. There are some other differences with different materials, but generally we're looking at 45 days. If it's not back in 45 days, there's some exception reporting that needs to be done on the generator's behalf as far as, okay, why haven't you gotten your waste manifest back? What's the deal? Is it, do you know where it is? Sort of thing. They just basically want to avoid something getting lost in transport or having been illegally disposed of, God forbid. So get that waste disposal manifest documentation back within that 45-day period. Then close out submittals. A lot of things you're looking at: your waste shipment records, your OSHA compliance, air monitoring logs, daily logs, final notifications, variances, all monitoring reports, remedial action reports. That's all important documentation to have on file after abatement remediation project in case you got to go back to it and see what was done and or if there's a question later on at the site, you can look back at those documents. Step 7 is the record keeping. So once we have those documents, we have those files, who keeps a record of it? Well, the abatement and remediation firm should have records of all those files. They should keep those until basically they're no longer in business. Medical records for employees associated with remediation projects. There's an OSHA requirement for 30 years past the employee's termination date. On the environmental consultant side, the monitoring firm, they should also be keeping the files and records of reports until they're no longer in business. And again, OSHA, they have their medical records and for their employees maintained, again, 30 years past that employee's termination date. And the owner, they're going to want to maintain records. Obviously, they're going to be the easiest source to access records on a property. The abatement firm, environmental consultant, once they're done with the project, they may no longer be associated or affiliated with that site ever again. So the easiest way to get those files is going to be through the owner. So obviously, as long as they own the property, they should maintain those records for the duration of ownership and then transfer those records with the property ownership. So the next owner will have those files so they can manage their property appropriately. All right, our step 8, the final step we're looking at is long-term management. Sometimes you're going to have remediation that does not go the full circle, the complete. It's not completed fully. Whether there's obstacles in the way, if you have a building on a site and you can't fully excavate soil, you have depths you can't reach, or if you leave asbestos materials or something in the building, you're doing enclosure encapsulation or manage in place, you're going to have things that you got to deal with on a long-term management basis. That might be for remedial systems. You might be looking at an operations and maintenance plan to make sure the system continues to function as it's supposed to, monitor that system, and then sampling from time to time to make sure the long-term effectiveness of that remediation system is working. It's accomplishing your goals or it's continuing to move towards those goals. And if not, does a different system need to be installed? When you look at encapsulation and closure, you want to inspect those on a routine basis, make sure they are still functioning as they're supposed to. And if they're not, you do the repairs. A lot of times you're gonna have to bring a contractor back in to do those repairs. That's the detriment of trying to do a long-term management type thing in encapsulation and closure versus a removal. But make sure that you are inspecting them and they don't get to a point where they're beyond repair and you got to do a full-on removal or cleanup process. Site controls, you might have deed restrictions, so you can't use the land or the property in a certain manner. It might just be a restricted industrial commercial use, and you can't ever use it for residential, so that's going to go with the deed. It's important to know that and transfer that with the property and make sure the next owners are aware of those conditions. Or you might have a cap or treatment system, how you deal with managing a site cap or a site treatment system. And then management plans, inspections, management protocol, training, plan updates. So this might be something you implement for on-site employees or maintenance personnel, so they know how to maintain a property and avoid any sort of disturbance of contaminants that are going to continue to be on site. All right, that brings us to our final two questions.
Cheyenne, you can continue.
All right, question 4, what is the typical time frame for returning waste manifest to generators before an exception report needs to be submitted? The answer today is 45 days. All right, so we doubled up on questions here, so here is number 5.
I do apologize. It looks like we're having an issue where it did this 4th question in duplicate and it did not include our 5th question on us.
Okay, so question 5 is a freebie. How long must the employer maintain medical records pertinent to employee engaged in hazardous materials remediation work? And the answer there would be B, 30 years past that employee's termination date. All right, so just a quick recap before we finish up here on life cycle of a hazardous material project. Basically, we're looking at 8 different phases. First, we're going to define our project. Then we're going to survey and assess it. Once we have survey assessment data, we want to go through the planning and design stage to make sure that we detail how they should go about doing the remediation abatement and what they should be remediating and abating during the project. Then we're going to get into the actual work that takes care of that hazardous materials or the contaminant concern. Site restoration, waste disposal. Follow that up with project closeout documentation, record keeping process, and finally the long-term management if you do have contaminants of concern that remain on site and how you're going to inspect, monitor, and sample for those. So that is all I have for today on that. I appreciate your attendance and thank you very much.